What is up, guys? Welcome to Algebra 2 2020 style. We are starting off the year with graphing some absolute value functions. So 2 goals today: graphing an absolute value function and identifying key pieces of an absolute value function. So you notice the notes look a little different if you had me before in class. We tried to do a little more of a Cornell note style. So just off to the left here, just a little note. Anytime you have questions or you want to remind yourself of something, put them over here. Everything else will fill in over on the right side. So starting with some vocabulary, what is an absolute value? What does that mean? That is basically what we're going to call magnitude. There we go, magnitude. Another way of saying distance. So we'll just call it distance. It is from 0 on the number line. The distance, a point is from 0 on the number line. It's just another way to think of it. So an absolute value function then is it's a function with, we got these kind of bars, function with the absolute value symbol. Okay, so you're looking for these 2 bars, just kind of straight up and down. The vertex is going to be the minimum or maximum of the absolute value function. And just a good review of domain and range. These are all possible inputs, which, fun fact for you, is going to be all real numbers for absolute value functions. You can put any number, any real number that you can think of, you can put it into an absolute value function. Now, if you don't want to write all real numbers, which you can, we can use this symbol here. It's kind of like a double line and then an R over the top of it. That is a symbol you can use to write all real numbers to save yourself a little bit of time. The range is going to be all possible outputs. Okay, and with absolute value functions, it's going to correspond with the K value. We'll talk about what that K value is here in just a second. So the first example is just talking about the general form of an absolute value equation. Y equals A on the outside, and then here you have those absolute value bars. So there's the absolute value bars. Inside the absolute value, you have x minus h and then plus k. So how do you look at an equation in that form and find the vertex? It's actually quite easy. It comes from the h and k values. Now, I would suggest writing yourself a note here. So I'm just going to put a little star, note the h value will change signs. So we'll talk about that with an actual example here. Maybe you want to also write here h equals horizontal shift and k equals vertical shift. Well, okay, so h is going to move your vertex left or right. K is going to move your vertex up or down. So let's talk about now the a value. This little number out front, what is that going to do? So just like parabolas, if you remember doing that, the roll of a will opens up or down. So it's going to tell you whether your absolute value graph will look like a V or an upside down V. It also tells us the steepness of the graph. Another way you can think of that is the slope, okay? So steepness or slope. The domain, like I said, is going to be all real numbers. For absolute value functions, you can place any real number that you can think of into the absolute value function. That is going to be the x values. The range is going to be all, actually I'm not going to use that word all. I'm going to go possible output numbers, aka the y values. Okay, so finding your vertex, kind of using A as almost your slope, and then determining whether your graph's going to open up or down is going to be the main part, and then we'll just have to determine our domain and range. So here we go. We start off with an actual example. Graph the absolute value function y equals, and then we have the absolute value of x minus 1 plus 2. So starting off, I'm going to go ahead and label. So A is going to be right out front here between the equal sign and the first absolute value bar. H is right here, and K is out back. So my vertex is going to be made up of H and K. I put a little note up here that said the H value is always going to change sign. So it looks like your H is -1, but actually your H value is +1. And then your K value is always going to be whatever it looks like. In this case, it's +2, so it's going to be +2. So that just the H value, you have to worry about changing that sign. So my A value, if you don't see an A value up front here, it's always going to be a number. That number is going to be 1. If my A value was 0, this whole thing wouldn't exist right here, but it does exist, so that means that A has to be 1. My domain, so here's how we're going to write this. We know our domain for all absolute value functions is every real number. So we're going to say that x is in, it's kind of like a curved E, and then the double R means all real numbers. So x is in the real numbers, every real number you can think of. And then the range. So we said that the range had something to do with the K value. Let's graph this first and then see if we can't figure out what type of numbers we're going to get out of our absolute value function. So starting with our vertex is 1, 2. So we're going to start at the origin. We're going to go to the right one, up 2. There we go. Now use A. A is your slope. So you're going to count rise over run here. So actually I'm going to put a little note as well. So it's going to open up. So from that point, I'm going to count up because my vertex or my A value is telling us our graph's opening up. I'm going to count up 1 over 1, rise over run, up 1 over 1. And you can do this, at least 3 points on each side. Or if you really like your graph to look nice, you can go all the way until you can't plot any more points. Now, absolute value functions, they're always V-shaped or upside down V-shaped. For now, anyway. So that means you're just going to reflect those points over and go up 1 to the left 1 to get that V shape. So here you have the graph of the absolute value function y equals the absolute value of x minus 1 plus 2. So the range, what numbers are coming out of here? Well, we wrote a little note up here that our range is the y values. So y, now if you look, we have our graph starting here, and it's going to be everything above there on both sides. So how can I write that in symbols? Well, I could say that the y values must be greater than or equal to 2, which also happen to be our k value. Okay, so there's our first absolute value example. So let's take a look at another example. Graph the absolute value function y equals -2, and then the absolute value of x plus 2 minus 3. So here's A, H, K. Starting with my vertex. It's coming from H and K, but H, make sure you flip that sign so it's actually -2, -3. I'm going to go ahead and plot that right away. Here's my vertex, left 2, down 3. My A value is -2, which means it's going to open down. Okay, so I know I have something that looks like that going on now. My domain, x is always going to be in the real numbers, always for every absolute value function. And then my range, I know it's going to be y is something compared to -3, my k value. I know that. I have to figure out are my y values going to be above -3 or below -3, and then we can move on. So using my slope of -2, because I know this absolute value function is opening down, that means from my vertex, I'm counting down 2, rise over run, 2 over 1. So down 2 to the right 1. Down 2 to the right 1. Again, at least 3 dots. You can keep going to the end of the graph if you'd like. And then we can just reflect those points over our vertex. I should have made that a different color there. There's our vertex. We can reflect those points. You're down 2 to the left 1, or like I said, just reflect them. And there you have our absolute value function. So looking at that graph, can you tell me if the range is going to be above or below -3? Well, here's that -3. And hopefully you can see that everything is below it. So then we want to say that y is less than or equal to -3. So last example, pick up the pace here with A, H, K. My vertex is going to be -3, -1. My A value is +1/3. It doesn't matter that it's a fraction, it's positive, so that's going to tell us that it opens up. My domain, x is always going to be in the real numbers. And my range, y is going to be what compared to -1? Well, because our graph opens up, that means the y values must be greater than or equal to -1. So let's graph this and see if we got everything right. Vertex is going to be -3, -1. So we're starting here. Then use that A value of 1/3 to count rise over run. So up 1 over 3, up 1 over 3. I'm going to go as far as I can to the right. And I'm going to go up 1 to the left, 3 to the other direction. And there we have our absolute value graph. And you can check our range. Here is that -1. And everything is above it, so we did get our symbol correct there. So now here's how this is going to work for you. There's 2 problems on this last page. Take a look at them. They're very similar to what we've already done. Graph these. When you come into class in person, there's 3 actually, sorry, 3. When you come into class, I'm just going to check these to make sure you took notes, and then I'm going to check these 3 problems to kind of see how it went. And that's going to be it.